Hi, everybody. This is part 2 of section 13, which is on multiplying polynomials. And this will also contain section 14, the first part, which will be factoring out the GCF. So we're going to do both in this one video. So first, let's finish off polynomials, section 13. We're going to focus on two methods. We're going to focus on multiple distribution and the box method. So multiple distribution is basically distribution. It's exactly what we remember, hopefully you remember, to do for distribution. So here I'm multiplying 4x cubed, 4x to the third, which is a monomial, that's one term, times a trinomial, which is a three-termed polynomial. So in order for me to do that, I have to distribute the 4x to the third to every term inside the parentheses. I have to remember a little bit of my exponent rules in order to do that. I'm multiplying x to the third times x squared. So that's 3 x's being multiplied by 2 more x's, and I combine the exponents. I add the exponents. So, and the coefficients I can multiply like normal. So this is going to be 4 times 5, which is 20. But then when I add the exponents, this is going to be x to the fifth. Then I multiply 4x to the third times negative 2x. That's going to be negative 8x to the fourth. The reason it's a 4 is because there's that 1 on this x. So I'm combining this 3 plus 1, getting the 4. And then I multiply 4x to the third times 5, and I get plus 20x to the third. So just a single distribution there, multiply everything through the parentheses. Now let's look at the next example with this concept of multiple distribution. I'm going to pretend that this minus 5 is not there. So I'm going to look at it as if it's just one term that I'm distributing. And I'm going to draw those arrows. I'm just going to distribute the 2x to start. That's going to give me 8x to the third, because I add the exponents, minus 14x squared plus 6x. But I'm not done. That was only my first distribution. Then I go back and I take my finger off and I look at that negative 5. I'm also going to distribute the negative 5. So I'm going to multiply negative 5 by all of these terms. Negative 5 times 4x squared is negative 20x squared. Negative 5 times negative 7x is plus 35x. And negative 5 times 3 is minus 15. Now, I'm done with my multiplying, but I'm not done with the problem because I see that I have some like terms within my answer. So I have these x squareds that can go together, and I have the x's that can go together. So my final answer here in descending order will be 8x to the third. And remember, you can cross it off as you use it. When I combine these, I get minus 34x squared. When I combine the x's, I get plus 41x, and then minus 15. Now for this one, I'm going to show you another technique called the box method that also works pretty well here. And it's just like what it sounds. I'm going to draw a box. And on one side of the box, I'm going to put the terms of the first polynomial, so 2x minus 5. And I'm going to slice the box in between the terms. So each term has its own piece of the box. On the other side of the box, I'm going to put the terms of the other polynomial. And then I'm going to slice the box in between those terms. And you can see that now each of these partitions has a term on either side. The product of those two terms goes in the middle. So here I'm multiplying 2x times 4x squared. That's going to be 8x to the third. Here I'm multiplying negative 5 times 4x squared. So I get negative 20x squared. And I do the same thing for each of the surrounding parts of the box. So this is going to be 2x times negative 7x, so negative 14x squared. This is going to be plus 35x. This is going to be 6x. This is going to be negative 15. Then I can see that like terms are now in the same vicinity. My x squareds are right here. My x terms are right here. And now I can write my final answer in descending order and also combining like terms. So I would start with 8x to the third. When I combine these terms, I get negative 34x squared. When I combine these terms, I get plus 41x and then minus 15. And notice how you get the same answer no matter which technique you use. And that's why I'm showing you multiple techniques here, because you can pick the one that makes the most sense to you. I personally will do it this way, using the arrows like we traditionally would do in class. But a lot of students like the box method because it keeps everything very organized. So that's a method that a lot of students choose to use. Whatever technique makes the most sense to you is totally up to you. You can use whichever one you want to multiply because they're going to get you the same result. Okay, let's continue. Here's our next example. I want to multiply a binomial, 4x plus 7y, two terms, times another binomial, 3x minus 2y, two terms. You might have learned another technique for this called FOIL. FOIL stands for first, outside, inside, last, or first, outer, inner, last, depending on how you learned it. And all that stands for is a way to remember which ones you're multiplying. So first means the first two terms in the parentheses. Outside means the two outer ones. Inside means the two inner ones. And then last means the two last ones in the parentheses. But if you think about it, there's no need for you to do that if you understand this concept of double distribution. If I just do the same that I was doing in the previous examples, I don't have to remember another technique. So if I distribute the 4x first, I would get 12x squared minus 8xy. And then if I distribute the 7y, I would get plus 21xy. And the only reason I'm putting the xy first is so I stay consistent. And then minus 14y squared. I can see that these are like terms. They both contain xy. And so my final answer will be 12x squared plus 13xy minus 14y squared. Okay, next example. Here I'm multiplying three things together. You have to be careful here. A lot of students want to distribute the 3 all the way through. You can't do that, okay? You have to only multiply 2 things at a time, all right? So we can only focus on one pair to start with. Whatever pair that is for you is up to you. So we're actually going to do this 2 different ways. First, I'm going to multiply by multiplying the 3 times the 2x minus 4 first. So I'm going to multiply the first 2 together first. If I do that, I get 6x minus 12. Now, that's a new polynomial. So I'm going to put that in parentheses and I still have to multiply by x plus 5. So I have to copy that down. Now I have to multiply these two binomials together. So I'm going to do the double distribution and get my terms. So that's going to be 6x squared plus 30x minus 12x minus 60. Then I combine like terms, and my final answer would be 6x squared plus 18x minus 60. Now let's do the same problem, but this time let's multiply the two binomials first, and let's leave the 3 to bring in last. So I'm just going to copy down the 3, and I'm going to create a new polynomial by multiplying 2x minus 4 times x plus 5. If I do that, 2x times x is 2x squared. 2x times 5 is plus 10x. Negative 4 times x is negative 4x. And negative 4 times 5 is negative 20. Then I can combine like terms. And what's left inside is 2x squared plus 6x minus 20. Last but not least, I bring in that 3. And my final answer is 6x squared plus 18x minus 60. So it does not matter which pair I decide to multiply first, but the point is you can only multiply 2 at one time. So pick the 2 that you want to multiply. Now let's see how good we are, and let's try a trinomial times a trinomial. If I'm doing this concept of multiple distribution, I should be able to multiply as many terms as there are. So I'm going to hide the negative 3x plus 1. And I'm just going to pretend that it's a 2x squared that I want to multiply. So if I follow those first arrows, I'm going to get 8x to the 5th, because remember, I add those exponents, plus 10x to the 4th, minus 6x squared. So that's 2x squared being multiplied by all 3 of those. Now I have to go back and I have to multiply by negative 3x to get my next 3 terms. So that's going to give me negative 12x to the 4th. That's negative 3x times 4x to the 3rd. Negative 3x times 5x squared is negative 15x to the 3rd. And negative 3x times negative 3 is plus 9x. And then last but not least, I have to multiply by the 1. So my last 3 terms are going to be plus 4x to the 3rd, plus 5x squared, minus 3. There's a very quick check here to make sure that you've multiplied through all the terms. This is a trinomial, 3 terms, multiplied by another trinomial, 3 terms. 3 times 3 is 9. There should be 9 terms in my distribution. 1, 2, 3, 4, 5, 6, 7, 8, 9. So at least I know that I fully distributed all of my terms, okay? I have the right number of terms. But I'm not done, because I'm going to still need to look for like terms that I can simplify. So I see that there are x to the 4th terms that I can put together. I see that there are x squared terms that I can put together. I see that there are x to the 3rd terms that I can put together. So a different shape around each set of like terms. I'm still going to start with the highest exponent. So 8x to the 5th Now my next like term would have been the x to the fourth. So I have 10 minus 12. So that's negative 2x to the fourth. So now those are done. Then I have negative 15x to the third plus 4x to the third. So minus 11x to the third. Then I have negative 6 plus 5, so negative 1x squared. Those are done. These don't have like terms, so plus 9x and minus 3 are just going to get copied down. And now this has no more like terms in it, so that's going to be my final answer. Let's do the same problem using the box method for those of you that might like the box technique. I'm going to draw a box, put the terms of the first polynomial along the side, split the box up into those 3 pieces, put the terms of the second polynomial along the other side, and then split the box among those terms. And now remember, the product of what is outside each box goes within. So this is going to be 8x to the fourth. 8x to the fifth, sorry. This is going to be negative 12x to the fourth. This is going to be 4x to the third. This is going to be 10x to the fourth. This is going to be negative 15x to the third. This is going to be 5x squared. This is negative 6x squared. This is plus 9x. And this is minus 3. And again, your like terms are in the same general vicinity. I can see that my x to the fourths are kind of near each other. I can see that my x to the thirds are near each other. I can see that my x squareds are close to each other. And so my final answer would be 8x to the fifth minus 2x to the fourth, combining those x to the fourth terms, minus 11x to the third, combining the x to the third terms, minus 1x squared, plus 9x, and minus 3. And look at that, I get the same exact answer no matter which technique I decided to use. So that's it for section 13. Okay, this is multiplication of any size polynomial. Okay, and you've got 2 techniques to choose from: multiple distribution technique or the box method. Now let's move on to factoring out the GCF. So the beginning of section 14. GCF stands for greatest common factor. Greatest common factor is the largest thing that they all have in common, that they can all be divided by. So those are your guiding questions for yourself. What do all the terms have in common? What can they all afford to give me? Okay, what can they all be divided by? So let's look at this first example. 4x squared minus 20x plus 16. All of these numbers can be divided by 4. So every term can be divided by 4. Whatever you identify as the GCF, you're going to write out front in front of parentheses. Inside the parentheses, you're going to write what's left. So when I divide 4x squared by 4, I just have x squared left. When I divide negative 20x by 4, I have negative 5x left. When I divide 16 by 4, I have a plus 4 left. Here's the good news about factoring out the GCF. These are checkable because I can redistribute the 4 and make sure that I get these terms back. 4 times x squared is 4x squared. 4 times negative 5x is negative 20x. And 4 times 4 is 16. So quickly self-checkable. Let's look at the next example. What are all of these terms divisible by? Well, if I just look at the coefficients, 25, -15, and 20 are all divisible by 5. So 5 is a good constant to take out. But what about the variables? This has x to the 4th, so there's 4 x's being multiplied in here. This has x to the 3rd, so 3 x's being multiplied in here. And this has x squared, or 2 x's being multiplied in here. They all contain at least 2 x's. So I'm going to take out x squared because they all can afford to give me x squared. Once I identify what they can all afford to be divided by, I'm going to write what's left within the parentheses. So if I divide by 5x squared, 25 divided by 5 is 5. And what do I do when I divide like bases? I subtract those exponents. So x to the 4th divided by x squared leaves x squared. If I divide -15x to the 3rd by 5x squared, I get -3, and then just x, because if I take x to the 3rd and I divide by x squared, there's only 1x left. And then if I divide 20x squared by 5x squared, all I have left is a +4 because the x squareds divide away. And that would be what's left in the parentheses. Again, I could easily check by redistributing this and making sure that I get the original polynomial back. Last but not least, what do all of these terms have in common? All the coefficients are divisible by 7. They all contain at least 1 x, so I can take an x out of all of them. That means my GCF is 7x, and now I'm going to write what's left when I divide everything by 7x. 21x to the 3rd divided by 7x is 3x squared, plus this will give me a 2x, and 7x divided by 7x is 1. Anything divided by itself is 1. If I neglected to put something here, it would not check. It wouldn't check out if I redid the distribution. So I have to make sure that if the entire term divides out, I put the +1 there. This way, when I go back to do my distribution, it will check out. So I hope this made sense. If you have any questions, as always, contact me and be on the lookout for the next video. Have a great day.